Howdy. Welcome to Discovering Creativity. My name is Nicola Fish, and I'm currently a master's in educational psychology student here at Texas A&M University. And I am just sitting here with David Conley, just going to go over a few questions, hopefully not take up too much of your time. Keep it light, keep it fun. And so just to start off, can you just tell me a little bit about yourself and what you kind of do on a day-to-day basis?
Sure. My name's again Dave Conley. Graduated from Texas A&M in 1983 in a degree with a degree in nuclear engineering, and currently I'm consulting in the space of systematic innovation. And so my day job now is to teach Fortune 500 companies and other groups, including governmental organizations, about the process of systematic innovation.
That's awesome. What was your first encounter or experience with systemic innovation?
Well, actually, that's a great question, because my very first job out of Texas A&M is I joined the Air Force and did research for them at the Air Force Research Laboratory in Albuquerque, New Mexico. And I expected each organization I joined to have some kind of advanced problem modeling and engineering solution generation tools. And actually, none of them had it. The Air Force didn't have it. Then I went to Johnson & Johnson in medical products, and I went to Philips Semiconductor, and I went to Intel. And even Intel did not really have a problem modeling and solution generation tool set that they taught to their incoming engineers. Years into my career at Intel, like 10 years into it, I was running a large automation team, writing code for the factories in order to help, the manufacturing processes. And a gentleman came into our team meeting, our departmental team meeting. I had about 25 or so engineers working for me, and they were trying to recruit people to come and learn about this process called the theory of inventive problem solving. And the more they described it, the more I realized this was finally that tool set I'd been looking for my whole life. And while some of my engineers went, I also pushed myself all the way through. And then I became Intel's lead of their worldwide innovation program my last 7 years with the company, and then enjoyed it so much, I just decided to jump off the pier into the lake and start my own consulting firm in the world of innovation.
Wow, that is so incredible. That takes a lot of time, patience, and I think a lot of deep studying, I'm sure.
Yeah.
And so if you're talking to someone who's never even heard of TRIZ before, how would you kind of begin those beginning steps of teaching them about it, explaining them, just kind of in a general sense?
Yeah, I understand. Good question. It is tricky whenever you have a brand new concept to teach to somebody or to introduce to them. The way they learn is they compare it to things they already know. And when it's brand new, it's very hard to pick what to compare it to. And so whenever someone is introduced to a brand new thought process, it can, at the very beginning, be like, what the heck is this guy talking about? But in order to try to make analogies to existing things, it is a method by which you can model a problem, and you can model problems in mathematics, chemistry, even probably psychology, all kinds of different areas. And then you apply some kind of tool set to turn that modeled problem into a modeled solution. And so Triz was a method that was built on a study of the worldwide patent database to understand how engineering systems changed over time. And it is all about resolving contradictory requirements within a system. For instance, a very large gasoline engine can give you a ton of power for your vehicle, but it consumes a ton of fuel to do so. That's a contradictory requirement. It's awesome to have all that power, but consuming all that fuel is not great. In general, in engineering, when we try to solve that problem, we just change the teeter-totter, and we go from then a huge V8 engine to maybe a small one-cylinder go-kart or lawnmower engine, which gets okay power, not much at all, but doesn't burn a lot of fuel in doing so. That is not solving a contradiction. That's just changing your design point. Solving the contradiction is where you get excellent power and you also get excellent fuel savings. For instance, there are now V8 engines which can run on 2, 4, 6, or 8 cylinders, depending on whether or not you're calling for a bunch of power or you want low fuel consumption cruising at highway speeds. So that is a solving of that contradiction of power versus fuel. Triz is all about modeling problems and solving contradictions within them. And this can be engineering or business type problems. It can be applied to almost any kind of system. And it is quite unique in that it actually has a solution generation engine built into it also, unlike almost most all problem solving techniques, which just tell you to brainstorm.
Yeah, I know when I first was assigned to meet with you today, I did some research on trees, and I was like, how have I never heard of this? I mean, it makes so much sense to kind of use that, that kind of diagram and that connection to solve those problems. And so I was even sitting down, my sister's in medical school. And so we were sitting down kind of going over it together, and it was interesting to see how it could also fit into, her world of education and career. Yes. Stuff like that. So it's very universal almost, I would say, which is really quite impressive. So given that information and everything, do you think just based on the fact that it's less brainstorming compared to the other creative problem solving tools, stuff like that, would you say, like in other words, like how else do you think that Triz is a stronger creative problem solving tool in comparison to those other tools that are available to just people in general?
Sure, that's a good question. Now, I do want to throw out there that there's a whole bunch of tools out there: Lean, Six Sigma, theory of constraints, all this stuff is good. And actually, you can put Triz into those also. You can model your problems through them and then solve them through Triz. But I think one of the most beautiful benefits is that Triz is a study of how systems have changed over the last couple of 100 years. And it didn't design innovation. It studied how people innovate and saw that there were very similar changes made in very different kinds of engineering systems. And that these different kinds of changes are pretty ubiquitous and pretty consistent. And so once you know how the system works, you can start forecasting the future state of things and start using this whole same concept to resolve contradictory situations within your systems. And again, a contradictory situation could be, I need a very large battery for my cell phone so that it can run for a long time. I need a very small battery for my cell phone so that it doesn't have a giant form factor. I don't want this giant brick of a battery here so I can talk for 4 days. And so you need to be able to have both of those happen simultaneously. Very long uptime on your cell phone and a very small form factor simultaneously. Triz helps you identify contradictory requirements, and the better you can focus on the problem you're trying to solve, the more elegant solutions you get out of the Triz process.
Yeah, absolutely. So then my next question is going to be, so when you're doing these studies or when you're like helping consulting or you're working with students, you're training people on using Triz, are there any like common misconceptions or mistakes that you see are oftentimes made when you're kind of in those initial stages of teaching people?
That's a good question. There's a whole bunch of different ways I could go on that one. I will tell you that humans have evolved to jump into solution generation, right? As soon as they hear a problem, they want to solve it. Mm-hmm. And actually, that's not the best way to proceed. It's best to identify very specifically the root cause of the problems you're trying to solve. And once you better focus the problem definition, then the solutions become almost self-evident. So in other words, humans try to jump right into solution space, but if you spend about 80% of your problem solving time in problem definition, and Einstein, Lincoln even made similar comments. If you had 8 hours to cut down a tree, you should spend 6 hours of it sharpening your axe. The better you define the problem, the easier the solution generation is. And a lot of people say, well, we don't have time to do this. We're in a rush. I've solved problems, for instance, at Intel that existed for decades. And yes, it does take, several hours to really analyze the problem before you go into solution generation space. But several hours of doing problem identification is way better than 10 to 20 years of an unresolved problem.
Yeah, absolutely. With that, when you're like teaching people or consulting, stuff like that, do you have one success story that might stick out to you that's just always in your head when you're thinking of, we solved this really complicated, like something at Intel for all those years, stuff like that? Is there one specific memory that you can share that might stick out to you?
Yeah, I actually have dozens and dozens, but I will pick one. When I was a Triz student at Intel, and it was my Triz class project, and we had a problem where we were having dirt particles on the wafers at the back end of the process. This is after we've come out of fabrication, and we have a giant wafer with all the die on it, and we run them through basically prober handlers, which do a quick touchdown on every die for about 2 seconds and runs a massive array of tests through it. And it's the testing process to make sure the die work properly before we package them into the little containers that they would plug into your motherboard on your computer or whatever. And since this was out of the actual fabrication building, which was a class 1 clean room, we were a class 100 clean room, you would get little dirt particles, and these probe tips that would go down and touch on the die, there were thousands in just like a quarter of a square inch, these probe tips. And each probe tip cost $5,000.
Oh, gosh.
So we're talking thousands times $5,000 per probe head.
Yeah.
And just a speck of dirt could break a probe tip. So I took this in to solve this problem and thought that I was probably going to have to rework the air handling system and the cleanliness of the floor. And I realized, so I can't just turn this floor into a class 1 clean room. That's super expensive. And we're not even in that part of the building anymore. It would take so much facilities modification. And it finally hit me. We only needed those particles, and this was through the Triz process, the thinking through it and defining the problem, that I only cared if there was dirt on these probes at the exact instance the probe tip touched down. I didn't care if it was on before, and I didn't care if it was on after, just during touchdown. And we put air knives, which are these little bladed, air sheets, on the prober handler. So as the wafer went in, it just had this very strong gust of air remove all particulate from it just for its probing period. And the implementation all the way around the world for all of our assembly test sites was only about $3 million. And we reduced the cost of probe card repair by $300 million per year, $350 million, and the solution cost a couple of $1 million. So super powerful process.
Yeah.
And it's all about, and it was that simple. And once you hear that and you say, well, the dirt just can't be on there at the time of probing, everybody goes, well, of course, that's just obvious.
Mm-hmm.
Well, for decades, it was not obvious, and we couldn't get there. But it is this process of mental inertia breaking that's built into Triz that can help you get to the aha moment of, oh my gosh, we've been going about this the complete wrong way.
Yeah, so it just kind of gives you that whole other perspective on something that's stumped people for, like you were saying, decades.
Yes.
That is a very good success story,
Yeah.
I will say. So you've kind of already touched on this before, but just kind of to go over the question again, what deciding factor, whether it was one instance in particular, that kind of gave you the aha moment of where you wanted to found Innovation Corp? Like, what was kind of that final stepping stone that like put you over the edge of saying, I'm going to do this?
Well, it's kind of interesting because the majority of what made me do it was all positive experiences at Intel and with the process, and just how much, I read a Scientific American article years ago that the more you directly help some people in your professional career, the more you enjoy your career. And it had like priests and firefighters and policemen and stuff towards the top of this, and then different kinds of engineers depending on how much they directly help somebody. Like an ergonomics engineer was pretty high on that list. Electrical engineers were lower because they design cell phones and stuff, but they're not working directly with helping people. And I just found that really helping people solve problems was awesome. But then, so I had all this positive stuff pushing me there. But then I must admit, Intel went in a different direction and kind of got to be not as much fun to work at as anymore. They used to actually have fun on your badge, and they took it off as a value, which is kind of a jaw dropper.
Yeah.
I can understand if maybe you don't want it on your badge in the first place, but if it's on there, taking it off sends a heck of a message. And once that came off, it changed at Intel, and I decided I'm having too much fun doing what I'm doing now. I don't want to stay in this environment and do it. And so I went out to do it on my own.
Yeah, I can only imagine. I mean, thinking about it psychologically, just seeing that taken off of that badge had to have been such a huge impact. I know I would have been like, are we not having fun anymore?
Right. It's almost like you shouldn't have fun anymore. Yeah, it was a jaw dropper, I have to say. I never forget the day that I got that badge and looked and went, what the heck?
Yeah, what happened here? Yeah. Oh my gosh.
And they backed it up.
Well, I hope you are having fun every day now.
Yes, I love my job.
That is awesome. And so in the future, how do you see the world of systemic innovation and Triz itself evolving in the years to come?
Well, I'm very interested. I'm going to jump back a second.
Yeah.
I did some work for the city of Milwaukee to forecast a future of artificial intelligence and machine learning. And this was funded by the Economic Development Association of the U.S. And I did a forecast on machine learning and artificial intelligence. I am very interested to see how that can help. Now, I will tell you, I have a lot of experience with software in related to systematic innovation. And overall, the operation of the software and allowing it to do the modeling and stuff removes you from the problem enough that it kind of messes up your ability to understand and solve the problem. And so I am not going to say that we're just going to hand AI, hand it this process of innovating. And maybe it will be capable of doing that in the future at some level. But I do think there are things that AI could be applied to the Triz process, but we don't want it to displace the human innovation. Humans are very innovative, and they can do free associations with things that I don't even know how a computer would make that up unless they just make it random. Our free association is not so much random. We don't know for sure how it works in our brains, but I don't believe that it's just this random, like spin this dial, see where it stops, and like, oh, cupcake. It's like our random association has to do with our experiences, other things we've learned and things we've seen, and say, oh, well, maybe this is associated with this kind of concept. I think AI can help pull up some information that can give us ideas about solution directions. So I am interested and have started working a little bit on how to incorporate AI into the Triz method, but without destroying the method's ability to help individuals innovate.
Yeah, I'm actually really glad that you brought up AI. I did watch, I believe it was either a panel or a podcast that you were on where you actually discussed AI within systemic innovation, stuff like that. And I thought it was really interesting how you brought up like almost, I believe it was like a counter AI to kind of almost like before the AI was completely set on to say like, is this, kind of how humans would think? Or it was in something like that where it was like a counter. And I thought that was really interesting because especially with the boom and the bang of AI these days, I think that there almost needs to be more of a close attention to the human part of life that brings it so much diversity and change and just new like novel ideas. So I am glad you touched on that, because I did watch that and I was really interested to hear kind of more on your side about it.
Yeah, excellent. Well, Nicola, I'm glad you brought that up. So one thing that I forecasted that is going to happen in AI, and really should, is that we're going to have collaborative and competitive AI systems. So for instance, that's kind of like, two heads are better than one concept. You can have collaborative AI systems where either they all try to solve a problem simultaneously, compare the results, and then decide the best path to go, or they all try to address the problem completely differently and actually compete with each other. And the biggest deal in AI right now is is having the data that goes into it be valid and applicable to the situation that's being done, so you don't get hallucinations in the AI systems and so forth. And so one of the biggest things I think we're going to see in AI is third-party organizations which start doing, if you will, data curation for either custom data curation for certain types of AI projects or general data curation so that it can be fed into AI systems to make better decisions. Right now, you think about just going to the World Wide Web and pulling information off. We all know you can find some incredible information and some complete bonkers
Baloney.
stuff also, right. And AI doesn't always know the difference.
Mm-hmm. Yeah, absolutely. That'll definitely be interesting to see, especially like on like my side of the world with like education, working in higher ed. There's obviously a big AI situation going on in terms of,
Yep.
plagiarism and all this kind of jazz. So it'll definitely be interesting to see how it can be incorporated in those problem solving tactics and be utilized in a way for more accuracy and betterment and enrichment of people just overall all around.
Yep, I agree. It's going to be interesting to see how we proceed with AI. The government does need to get in and and see what they need to do about controlling what's happening with it right now, but I'm not sure how and when that's going to happen.
Maybe the next time we talk, there'll be more out there for us.
Right.
So kind of final question, just to end us off in a fun little Aggie note. So reflecting back on your years as an Aggie, how different is your career path now from the one that you originally planned as a student in your undergraduate days at College Station?
Well, it couldn't be more different for two reasons. First of all, as we all know, the younger you are, I know there's some people that go to school and they're like, I'm going to do this with my life, and boom, boom, boom. Most people are like, I have no idea what I want to do with my life. I have to tell you, I got into my career path kind of a haphazard way. I was going to school at Del Mar Junior College in Corpus Christi studying geology. And one of my very good friends that I graduated from high school with, his brother was driving to College Station for the weekend to go visit his brother and asked me to join. So I joined them and I went down and I was blown away by the campus, even back in 1979, right? It was phenomenal, jaw-dropping. I'd never seen anything like it. And I decided I was going to go to school there, and I applied, and I had to pick a major, and I was going through the catalog, and I ran across this nuclear engineering. I had no idea what it even was, and I was just like, God, that sounds so awesome. I got
a little different from rocks.
Yes, very different from rocks. And so I was blown away, and I studied it, and even while studying it, it was awesome because I didn't know this, but I was setting myself up to be a generalist because they taught me electrical, mechanical, civil, nuclear engineering. I had 4 different primary engineering focuses through A&M. And then my junior year, they brought somebody in to tell us what we were going to be doing with our careers, which I'd never even thought of. And they said, basically, I'm being trained to run a power plant. And I'm like, whoa, no, that is not what I want to do. And the Air Force picked people up, and we're taking them out here to Kirtland Air Force Base to try to convince them to come do research for them. And I was like, oh, I don't want to join the Air Force. But all my friends went They flew them out on a cargo aircraft. They came back. They had the craziest stories about lasers shooting down, remote operated devices and all this stuff. And I'm like, well, that sounds way better than running a power plant. So I joined the Air Force. None of them did. I didn't go on the trip. I joined. So the recruiting trip worked on me, who didn't even go on it. And I went and did research at the Air Force Research Lab and got assignments at Brookhaven National Labs, Sandia National Labs, Los Alamos National Labs, and NASA while in the Air Force. So I just got thrown into this super deep end of high-tech research. I had no plans of that at all when I went to A&M to study nuclear engineering.
Yeah.
And it just all went from there.
Well, thank goodness for that.
Yeah, it was a fun. Sometimes just happily stumbling along is fine. Just like be true to yourself and make good decisions when you get to decision points. You don't
just
have to know what's happening. Yeah, you just keep treasing your way out of it, right? but no, yeah, my life is. I never even imagined I would be doing this at this point in my life.
That is so incredible. Thank you so much for taking the time out of your day to come talk to me, explain a little bit more about what you do. It was really awesome, really insightful, really inspiring to get to hear from your side of the story on other than just, like I said, basic Google searches and research like that. It was awesome to speak to you face to face today.
Right on. I'm glad to be here.
There we go.
Giga Maggies.